Hello, Longhorns. This week we are starting a new unit and a new 6 weeks. And we're going to begin with quadratics. The unit covers quadratics, polynomials, and rational functions. But this week we're going to mainly focus on quadratics. So at the top of your notes, I would like for you to put your name, your class period, and today's date. And then we'll begin notes. All right, so we have a lot of different kinds of functions. The main ones that we work with a lot are linear functions, the constant function, and the squaring function, which we also call a quadratic. So let's discuss the degrees of each one of these. The linear function has a degree 1. The constant function has a degree 0, and the squaring function has a degree 2. Basically, whatever the exponent value is the value for your degree. Here we have a degree 1 because this is x to the first power. Here we have a degree 0 because we have x to the 0 power, which is just 1. That's why it's not shown here, because c is just a constant. And then here we have x to the second power, or a degree 2. This is also called a quadratic, and that's what we're going to be studying now. So what we have on this page is a quadratic in standard form. And this is important because we need to understand what the values for a, b, and c are. These are the values, these coefficients that are in front of x are the values we're going to use if we use the quadratic formula. Also, this form right here that you see in your notes is in standard form. So let's talk about the different forms. We'll be talking about the different forms later. So by the time you see these notes here, we'll have already completed this in class. So if you already completed this in class, then you can go ahead and fast forward. I'm going to just basically fill in these blanks for anyone who might have been absent on Monday. All right, so the graph shape is a U-shaped graph. The mathematical name describing the graph is called a parabola. Are the graphs symmetrical? Yes, they are. They are symmetric with respect to the axis of symmetry. To find the axis of symmetry, you would use the formula x equals negative b over 2a. You're going to get a solid number here for negative b over 2a, and that's going to be the value of the line that goes vertically up and down through your graph. And that's going to create your axis of symmetry. The point where the graph intersects the axis of symmetry is called the vertex, and we usually represent the vertex as HK. To find the vertex, use the following steps. First, find the axis of symmetry, find that x value. That's going to be your x value for your vertex. You then take the x value for your vertex and you plug it in to your equation and find the y value. This will give you your vertex value. The vertex tells about the horizontal and vertical movement of the graph in comparison to the function. All right, so please note that the vertex is only a point on the graph. The value tells us a lot about of information. If it is negative, the graph opens down and the graph has a maximum point. So see how the graph is opening down. It's going to have a maximum value for y. And if the graph is positive, it opens upward, and then we have a minimum value for y. So these are just some important aspects that we need to remember about parabolas and about the equations and what the equations can tell us about the shape and direction of our parabola. All right, so if a is greater than 1, then the parabola is said to have a vertical stretch, which means that the graph appears to become narrower or thinner. If a is a value less than 1 but greater than 0, the parabola is said to have a shrink or compression. Now remember, these are both vertical, the vertical stretch and the vertical compression, which means that the graph appears to become wider. So if you compress the graph down like a pancake, it's going to appear to be wider. Now for domain and range, the domain for all normal parabolas, the domain is all real numbers. Just like with most polynomials, the domain is all real numbers. In the range, we have two cases. If we have a minimum value, meaning that the parabola opened up, then the range is going to be that minimum value to positive infinity. If we have a maximum value, meaning that the parabola opens down, then the range is going to be from negative infinity to that point. So you have to remember that if you're, so make sure that when you're looking at your parabola, if it's opening upward, the range starts here, okay? And if you're looking at the parabola, if it's opening downward, the range starts at negative infinity and it goes up to this point here. So it's very important when you're writing range to remember those things, okay? Because if you write it backwards, then it's wrong. So in the first case, we're from the point to positive infinity. And in the second case, we are from negative infinity to whatever that point is. And that's it. All right, so in this next part of the notes, we are going to definitely take pictures of this on Thursday. So make sure that you have your notes completed by Thursday. We're going to pass the iPad to take notes of our, or take pictures of our notes, instead of you taking pictures of your notes and emailing them to me or uploading them to Canvas. You will be passing the iPad around, taking pictures of your notes in class. This is to alleviate any issues we've been having with students not being able to upload their notes or not being able to email them to me because their email wasn't working, or whatever possible other reasons we might have for not getting our notes turned in. So on Thursday, be expecting to having to take a picture of your notes in class with an iPad that I'm going to give you. I'm going to pass it around the room. All right, so in the next couple of pages, we have the three forms of the quadratic equations, and we're going to convert back and forth between the three forms. The first form we have is the standard form, ax squared plus bx plus c. The next one we have is called the intercept form, and this is a times x minus p times x minus q. You can see this is also sometimes called the factored form because you have your factors here of your quadratic. So if you factored your quadratic and you put it in this form, then that would be the intercept form, because when we solve for x here, we get the x-intercepts. And then the last one is the vertex form. The vertex form tells us where the vertex is, hk, and it also tells us what the value for a is. Okay, so let's look first at the vertex form, this one right here. All right, so HK is the vertex, meaning the graph moved right and left. So H tells us which way the graph is moving, right or left. A still has the same properties as described earlier. And the benefits to this form is that we know where the vertex is. We can find the axis of symmetry very easily. I'm going to abbreviate that as AOS, axis of symmetry. And we can tell approximately how much the graph is stretched or compressed. All right, so I'm going to take the standard form of this quadratic equation and I'm going to break it apart so that we can find the vertex form. We want to change it from the standard form ax squared plus bx plus c into the a times x minus h squared plus k form. So in order to do that, we're going to have to do something called completing the square. Now you may remember this from Algebra 2. I'm going to write the problem out and describe how we do this. All right, this probably seems like a lot of steps, and well, it is a lot of steps. The first thing we're going to do is we're going to break apart our standard form of our quadratic, this 2x squared plus 8x plus 7. I'm going to move this 7 to the other side of the equal sign and make it negative. So now I have 2x squared plus 8x equals negative 7. The next thing I do is I'm going to take my 2x squared plus 8x and I'm going to factor out the 2. Because remember, when you are completing the square, the value of a must be 1. So this value right here needs to be 1. The only way I can get that to happen is if I factor out this 2. So I'm going to divide it out. I'm going to put it on the outside of these parentheses over here to the side. Now I have x squared plus 4x inside the parentheses, and I still have that equal to negative 7. Now what I can do is I can take this x squared plus 4x and I can expand it and make it a perfect square. So when I make x squared plus 4x a perfect square, I need to take half of 4 and square it. So half of 4 is 2, and 2 squared is 4. So I'm going to put a blank here, and I'm going to put a blank here, and I'm going to add 4. So since I added 4 on this side of the equation, I also have to add 4 over here. And since I had to factor out the 2 up here, remember when we factored out the 2? When we add our 4 to the other side, we have to remember that we need to multiply that 4 times 2. Because here the 4 is going to be multiplied times 2. So when we add it over here, we still have to multiply this 4 times 2. So don't forget that step. So make sure you put that 2 on the outside of this one as well. Now, what I'm going to do is I'm going to factor this quadratic right here into its 2 binomials. Should be x plus 2 times x plus 2. Basically, this number right here is going to be half of the middle number. Whatever the middle number is, you cut that in half. That's what this number here is going to be. So I have an x plus 2 times x plus 2. That is the same thing as x squared plus 4x plus 4. Now what I can do is rewrite my equation that I've got here, and I can combine these two binomials into one and just say x plus 2 squared. So now I have 2 times x plus 2 squared, and then of course I move my 1 over to the other side of the equal sign by subtracting it from both sides. Now I have my quadratic in vertex form. I have my a, I have my h, and I have my k. So my vertex is going to be -2, -1. Because remember, it's inside the parentheses, so when I pull it out of there, I've got to change the sign. Okay, so my vertex is -2, -1, and it opens up with a minimum of -1. So my domain, of course, is all real numbers, and my range would be -1 to infinity. All right, in example 2, we're going to convert from vertex form to standard form. So we're going to do sort of what we just did, but in reverse. All right, so not quite so many steps this time. What I've done is I've taken the x plus 2 squared part right here, and I've broken it down into its 2 binomials. Then I take those and I multiply them together by foiling, and I get x squared plus 4x plus 4. Then I multiply through by the 0.5. I'm just going to distribute that all the way through, and I get 0.5x squared plus 2x plus 2, and then I still have this minus 6 on the end. So what I'm going to do now is just combine these terms, and my final quadratic is going to be 0.5x squared plus 2x minus 4. And then I'm going to graph this. All right, so it's pretty easy to graph because I know that My y-intercept is going to be -4, because if I make x 0, the only number I have left is -4. And I know my vertex is -2, -6 because of the vertex form of my equation. Up here, I know my vertex is -2, -6. So there's my vertex, -2, -6. -4, 0, or I'm sorry, 0, -4 is my y-intercept. So I know that if I go 2 spaces from my axis of symmetry, my axis of symmetry would be right along here. If I go 2 spaces to the left, I'll find another point on my graph, and then I can just draw a quick sketch of my graph. And once again, the final quadratic is 0.5x squared plus 2x minus 4. All right, in the intercept form, we have f of x equals a times x minus p times x minus q. And like I said before, this is called the intercept form because here we have our two factors, and when I solve for x, I get what p and q are. P and q are called the roots or the zeros. That means that the x-intercepts of the intercept form are p and q. A still has the same properties as described earlier in these notes. Earlier I forgot to mention that also if A is negative, it tells us which way the graph is going to open. If A is negative, the graph is going to open down, and if A is positive, the graph is going to open up. I forgot to say that again, so now I'm going to say it here. So the benefits of this form is that it's easy to find the roots, zeros. Sometimes they're called the solutions and sometimes they're called the x-intercepts. So if we're looking for those specific points on the graph, if our quadratic equation is in intercept form, it's easy to find those points. The next thing we're going to look at is transforming standard form to intercept form and vice versa. In example 1, we're going to convert this quadratic from intercept form into standard form, and then we're going to sketch a graph of the parabola. The first thing we need to do is multiply these two binomials together using FOIL. And since I have a fraction here, I might use the fraction, or I might just use the decimal form of 1/2, which is 0.5. So either one of those I can use when I'm foiling these two binomials together. All right, so I went ahead and left this in fraction form. And you could do this also as a decimal, doesn't matter to me. I went ahead and left it in fraction form. If you have any questions about how I combine these fractions, then you need to come and see me in tutorials, and we need to talk about fractions. All right, so we have 1/4 times x minus 3 times x plus 1/2. The first thing I'm going to do is FOIL this. So I have x squared, x times x is x squared, minus 3 times x, plus 1/2 x, minus 3/2. The next thing I'm going to do is combine these like terms in the middle. So I get 1/4 times x squared minus 2.5 x minus 3/2. The next step is to multiply through my quadratic right here by 1/4. So I multiply through and I get 1/4 x squared minus 5/8 x minus 3/8. And this would be my quadratic in standard form. Now I'm not going to try to graph this on this teeny tiny graph that they've given me on this page, but we might try to graph it on the board in class. All right, in the next example, we're going to convert -4x squared plus 24x minus 32 into intercept form. All right, this is a little bit shorter and a little bit easier to do. The first thing I noticed when I looked at this quadratic, -4x squared plus 24x plus or minus 32, was that each one of these numbers is divisible by 4. And since it's divisible by 4, I can go ahead and just factor out the 4. That makes life a little bit easier. So I factored out a negative also. So I factored out the -4, and what I have left when I factor out the -4 is I have x squared minus 6x, because when I factor out a -4 from 24, I have a -6 left over. And then when I factor out a -4 from 32, I have a +8. So I end up with x squared minus 6x plus 8. Then I factor this part. And this is pretty easy to factor. I just need the two numbers that multiply to give me 8, that add to give me -6. Well, that's going to be 4 and 2, and they both need to be negative. So I factor this out, x minus 4, x minus 2. I still have my -4 over here on the outside of the parentheses, and that's okay. This is going to be my a. My a is negative, and this 4 means I have a significant amount of stretch here. So I have two transformations going on here. It's a reflection and a stretch. I also have this these x-intercepts right here. This 4 is one of my x-intercepts, and this 2 is my other x-intercept. So this would be like P and Q. All right, so when I solve for x, I get that my x-intercepts are 2 and 4. And I know that my parabola opens downward and that the stretch is 4. So what I'm going to do is I'm going to count up 4 places, and I'm going to put my vertex right there. And then I'm going to stretch my parabola down to the negative, and there you have the parabola that opens downward with these x-intercepts of 2 and 4. All right, that's all we have for notes. Don't forget to put your name, class period, and date at the top. And we'll be practicing a lot of these problems in class together.